Bonjour and welcome to this fifth video of this GTL tutorial. In this video, we will start scripting our 3D. So now that our 2D is okay and properly set up, we can start focusing on 3D. The workflow usually when it comes to GDL is to start with the 2D, and then when all is good in that view, then we can easily make the 3D. Because in this programming language, you kind of have some 2D to 3D conversion in the sense that some 2D commands have their 3D counterparts. So basically, in order to see how it looks practically, we will first copy-paste our 2D scripts into the 3D script here. This will not do anything here. If I go here into my 3D view, nothing is happening. This is normal because this is basically only 2D commands here. But here, what we will do here is then comment out all the geometry, and we will first start doing the attributes. So the first one here is that there is no fill neither line type in 3D, so we can delete them. There is a pen here, and this is also kind of a good practice to have a different pen from 2D when it comes to this. So here I will create a new pen and I will give it a 3D suffix. This pen will obviously be a pen type parameter, and now I will have here the name as 3D contour pen, and by default I will give it the same color, for example 7. Here I will go back here and I will add this 3D suffix. Then in 3D we do not have fill, but we have a material here. The material part here will call for a surface type parameter, so either GS leg or GS top mat. Here to start with, we will go with GS top mat. And then we do not have a line type, but we kind of have a way to manage facets in 3D, which is with the resolve command. The resolve command look for one argument, which is of integer type. So here we will create this one command here, and we'll name it GS resolve like this. This is an integer parameter here, and I will call it resolution. Basically, what it is here, it is usually a multiple of 3 or 6, even better, and it will simply tell ArchiCAD the number of faces per curve. So here, if I do a cylinder, I will only have 24 faces with this parameter. Yeah. So here, let me fill it with GS result like this. Yeah. Let me check my script. All good. We can continue. Then what we have as a new conversion is the transformation. We have 2D transformation. We obviously have 3D transformation here. So here we will now switch all of our 2D transformation into 3D. How do we do this? Basically, is that the ADD2 command doesn't exist. It is replaced with the ADD command here, aid, and it needs a third argument, which is basically the Z value. And because we do not change the Z value here, we will put it 0 like this, and we will do the same for all the ADD. Okay, for this one, and this one here. Then we'll do the same with hotspots. Hotspots here are for the 2D. We simply need to delete the 2 here. We now have the hotspots command, which needs another argument, which obviously is the Z value as well. Here, here, and here. For this one, however, we will need another set of hotspots, because here we have a 3D geometry, and we also want hotspots at the bottom of the object and also at the top of the object here. So now we will also duplicate those 4 hotspots here, and instead of 0, we will put size X. That way, we will have the same spot, the same set of spots at the bottom and at the top, like this here. Let me check my script. Here, it tells me I have too much parameter. This is normal because I forgot to delete the 2 here. Same for the other one here. Now, all good. That's why the check script is really a good addition to test your code, and that it's always good to click on this from time to time. Then what do we have here? We need to uncomment the del, because now we have all the transformations that are properly set up. We do not have a counterpart for del because it deletes transformation whether they are 2D or 3D. So now they are good, and now the only thing remaining is the geometry here. Here, the poly2 do not have a specific poly because there is not. There is what they call prisms. So here I will uncomment this one like that, and we will have a look here in the 3D shapes like this. We will need to look for the title, which is bolded here in page 22. Here you can see that I have some basic shape here, and if I scroll down a bit, you can now see that I have prism comments. Similar to poly2 here, you can see that it has a similar way of having arguments, and also it has similar variants where you have underscore or here cprims underscore, or the same with the numbers, etc., etc. What we will use here is the prism underscore because it is very similar to the poly2 underscore here. The only difference here is that instead of the frame field, we have the height as a second argument here. So here, let's go back here and go prism that way. And now we do not need this status code here. We just need the height of the geometry here. This here is the panel. So what we need as a parameter is the panel thickness. Let me copy paste this and then replace it that way. Now let me check. All good. So now we will do the same here. We will have, and I can already tell you now, but we will have an issue with the representation when we will finish the conversion, because there is something more that we need to add to the poly to prism conversion. So here, copy paste prism underscore, here, here, and here. And here we have the legs. The legs are of full height, so we will replace the code with Isaac as well. Here, 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 and here. Okay, let me check my script. All good. Now we have 0 code that is commented out. Let us check the 3D. You can see now that there is no error in my 3D script. However, there is here some issues here. Let us go and open our 3D preview window. Here you can see that I have a panel, okay? And now you can see that I have some floating circles. The reason here is because first, we do not have the proper height for our panel. So we will here solve this issue first. Here you see that we have our panel, yeah? But we have 2 panels. We have one that is at the bottom panel height, and we have another one that is at the height. The height of a geometry in 3D obviously is at the bottom of it. The extrusion always go to the Z direction here. So yeah, if I want to put the geometry at the correct height, I will need to subtract the panel thickness. So here, this will go like this. I will simply create a new transformation, which will be a 3D transformation here. So here, let's go into 3D transformation. And you will see that we have some more transformation. You can see now that we have 4 types of ADD. We have used the ADD1, the normal one, which has 3 arguments. But you can see here that we have some that acts like shortcuts. For example, this one only needs 1 argument, which is the Z value. Those here 3 transformation are really useful if you only move into one direction. This is what we want to do with the panels. So we will use the ADD Z comments here. So that will go like this, ADD Z. And this one will go to the bottom panel height minus panel thickness, like this. And then what I will do here is that I will here delete this already. Like that, I am sure that I am not sure here in my code. So here, let's go back to our 3D window. And now you can see that my panel has moved already. We also need a second one because we have 2 panels. So here I will copy paste this. And instead of bottom panel height, I will use size X. Like this. Now, how does it look? All good. We can now see that we have our 2 panels here. So this is working correctly. Let us just check if I change here the bottom panel height value. Let it put at 2. It moves upwards. Let me change the size X value. It moves downwards. All good. What we now need to do is solve this issue here with the floating circles here. You can see that if you zoom out, my extrusion does not have any border. And this is the same reason why here I have the floating circles. The reason is simple. In 3D here, the status code are a bit more numerous. Let's just go back into the GDL reference guide. And what we will look here is status code like this. And we will look for the here additional status code like this status code syntax in page 211. You can see here that if I zoom, that we have 16 status codes from 0 to 15. What we have been using right now in 2D is simply 0 and 1, which is normal. In 2D, we do not have the Z dimension. So here we do not need to have if the edge is off or on, 0 or 1. But in 3D, we have the Z dimension, so now we need to introduce a new code, which is the number 2 code, and a new one as well, the 4 one, because the 2 will simply display the vertical edges, and the 4 will display the top edges. We also have a new code, which is the 8 value, which will display the face that is generated by the 3 edges, 1, 2, and 4, basically. And you will recognize that 1, 2, 4, and 8 are multiple of 2. That's kind of how it works with GDL when you have status codes like this. So what does it mean is that if I put 1 and 2, it goes 1 plus 2 equals 3. That means I will need the vertical edge and the bottom one as well. So if I need 6, 6 will be here 4 and 2, and you see here vertical and top edge here. Same, if I put 8, I will not have the surface that is visible. So now you can see that if usually I will need to have, instead of 1 in 2D, 15 and sometimes 13 if I do not want to display some vertical edges. So I have a curve that is a bit more smooth when it comes to its 2D representation. So here, what we need to do is change our Prism status code from 1 to 15, like this. And for our cylinders, we will need to change the 900 value here to 13, like this, sorry. And like this, we will now see that our geometry is not hollow anymore. And now if I go here into my 3D preview window, you can now see that my geometry is proper. The only issue here is that it is of the same color here. So this is normal, attributes impacts all the code that is below here. So here I have put the material that is the top material at the very top of my code. So here it will impact everything else. Usually when it comes to material, it is good practice to really put it directly above what it will impact. So here my GS top material will need to be above my prism here. And here, just above my leg, I will simply use the GS leg mat parameter. And now you can see that I have two different parameters here. You can now zoom in, and now you can see that everything here is full from my legs to my panels. You can also see here that I have some faces here in my cylinders. This is normal. ArchiCAD here is using meshes to represent the geometry. But here, if you want it to be a bit more faithful, you can add some more value here to the GSResult parameter. And now you can see that it is a bit more curvy than before. Important to note, obviously, if you have more faces, you have more geometry, and if you have more geometry, you have more calculation when it comes to shadows, when it comes to rendering, when it comes to manipulating your model. So this is important to have the proper balance between the faithfulness of the geometry and the sizes and efficiency of your model. So by default, I put it at 24. It's always good because from afar, from something like is a small furniture, you do not necessarily need something that is more curvy. But if you have a huge object that is often close to the camera in rendering or stuff like this, you may need to have here a bigger value, or simply letting this parameter be used by the users. So that is all for this video. The 3D is almost ready. You can see that there are some issues here. We have some Z-fighting. We have also some other problem. But we will solve this in the next video. See you on the next one.